8.5, adding and subtracting rational expressions. This means we're adding fractions today, but with variables in it. In the past, we've learned how to add and subtract fractions, both with a common denominator and without. We're going to extend those skills today to deal with rational expressions, meaning expressions with variables. So this first key concept kind of tells you what to do if you have a like denominator, which we should already be familiar with. If we have the common denominator, we just add the tops together, leave the bottoms alone. Or subtract the tops and leave the bottom alone. Below you can see a couple of examples, and we're going to work one out together on the next slide. So notice in example 1, both of these problems have a common denominator. That's the easy version. So we put our common denominator, which is 4x, and then we just add the tops. The numerator says 7 and 3, add those up, we get 10 over 4x. If you stop now, you miss a point, because you have to reduce. Then we're done. I recommend you pause the video right now and try part B on your own. Your common denominator was x plus 6. Top was 2x minus 5. Top and bottom both do not factor, so we can't do anything else. If you try to cancel out those x's, you made a mistake. You can only cancel things out if they factor out. Just like last lesson. Let's go ahead and pause the video and try these 4 problems. Notice they all have common denominators, but you still might be able to reduce on one or more of them. So be careful and check for that each time. The harder problems, this would be probably level 2 of 3 that we're going to see today, is when we don't have a common denominator. And just like we learned in elementary school, if we don't have a common denominator, we make one. We're multiplying top and bottom by whatever we need to. Typically, we need to find the least common multiple of the denominators. For instance, 1/6 plus 1/10. The best way to find your common denominator is to factor both of the denominators. And to identify your actual least common multiple, which will be your common denominator, you look at each factorization and take the highest power of each number. For instance, I see a 2, and it's raised to the first. I also see a 2 raised to the first here. I only need one of them, so I say 2 raised to the first. I also see a 3. The highest power of 3 I see is 1. The highest power of 5 I see is 1. Multiply all those together, we get 30. There's our least common multiple. We can then use that to add our fractions. We end up with 8 over 30, which reduces. We're going to use the same idea that we learned in elementary school or pre-algebra with rational expressions. So let's find the least common multiple of these two guys. These might be what you'd see as your denominators in the next couple of problems. To find the least common factor, least common multiple, you have to factor first. So this 4x squared minus 16 and 6x squared minus 24x plus 24, they're both factorable. You can use whatever method of factoring you want. Always take out that GCF first. Pause the video and factor both of these. See if you get the same thing I do. For 4x squared minus 16, I see we can take out a 4. We're left with x squared minus 4. You should have seen that that was a difference of squares. So we're left with x plus 2, x minus 2. And we want to factor that 4 as much as we can also. It's really 2 squared x plus 2 x minus 2. Factoring that 4 is going to help us with our GCF. Now we have the 6x squared minus 24x plus 24. Hopefully the first thing you did was factor out the 6. You'd be left with x squared minus 4x plus 4. You can factor that any method you want. It's a perfect square trinomial. You could have used Clinton magic. You could have used anything. Either way, you'd eventually end up with x minus 2 times x minus 2. Cleaning that up a little bit, 6 becomes 2 times 3, x minus 2 squared. So I now have my 2 factorizations. I'll highlight them both in yellow. To identify our actual LCM, we start looking at any factors. I'll start up top. I see a 2 squared, and on the bottom I see a 2 to the first. I take the highest power. 2 squared wins. Next thing I see is, and I don't need this 2 by the way anymore. Next thing I see is an x plus 2 to the first. Down below I don't see any x plus 2. So the highest power is x plus 2 to the first. Next up I see x minus 2 to the first and x minus 2 to the second. X minus 2 to the second has the higher power, so I keep it. So I don't need this one at all. I don't see anything else up top. Now I go to the bottom and look for things I haven't used. I don't need to use the 2 because I already took care of 2. I don't need to use the x minus 2 because I already took care of that. But I still need the 3. And the highest power of 3 is 1. So there's my LCM. It's kind of a long process. You've got to factor. You've even got to factor your numbers with a factor tree. But eventually you get to your LCM. Now we're going to see that in an example with fractions. So here's why we learned this LCM stuff. It says add with unlike denominators. The first thing you have to do is factor your denominators. You got to factor the 9x squared, you got to factor the 3x squared plus 3x. Go ahead and pause the video and try that on your own for practice. Hopefully you ended up with something like 3 squared x squared. And on the bottom it looks like I could take out a 3x. I'm left with x plus 1. 3 doesn't factor any further, so that's as far as I can go. I'm ready to identify my LCM. Again, I'm only looking at the factored versions of both denominators. Starting on top. The highest power of 3 that I see is 2, so I need 3 squared. The highest power of x I see is x squared, so I need an x squared. Down below I also see that x plus 1, so I need that. Now let's see how we're going to use that in the problem. I'm going to rewrite my problem in factored form. By the way, this becomes 9x squared times x plus 1. The first fraction was already factored. The second fraction, not so much. Now let's look at what we're missing from our LCM. I need 9x squared times x plus 1. My first fraction just needs the x plus 1, so I put it on top and bottom. My second fraction only has a 3, I need 9, so I'm going to need a 3 on top and bottom. I also need an x squared, but I only have x, so I'm going to include an x. I don't need the x plus 1 because I already have it. So my next step is to rewrite this whole fraction. I don't have to do anything with my denominator. 7 times x plus 1 I'll distribute. X times 3x is 3x squared. That might be my final answer. I should rewrite it in descending order. meaning highest degree first. Just in case something cancels, we should always try to factor that top. Try some Clinton magic. Two things that multiply to give 21, add to give 7. I don't think it works. Our only choices are 1 and 21, 3 and 7. Not finding anything. So we're done. There was a lot to that problem. Might be in your best interest to go back to the beginning and follow through 1 or 2 more times. Essentially what we did was factor the top and bottom, identify LCM, and then we applied the LCM. And our final step was simplify. It's kind of the process every time on these fractions. Next up is the same as last time, except now we have a minus sign in the middle. Shouldn't be too big of a deal. We still go through those same steps. We're going to find our LCM. And to do that, we need to factor. Go ahead and pause the video and factor both of these, see if you get what I get. I notice a 2 comes out of the first denominator. That's about all I can do. The second one, you can use Clinton magic or whatever factoring method you prefer. Should end up with this guy. Just like last time, the whole point of this is to identify our LCM. We'll go through that same process as last time, starting with my first factor, 2. Highest power of 2 I see is 1, so I write a 2. Next up, x minus 1. The highest power I see is to the first, so I write x minus 1 to the first. Go to x minus 3. The highest power I see is to the first. Next step, I rewrite the original problem. The denominators factored. That shouldn't take too much effort because we've already factored them. Now the part that matters most. We need to make these denominators match. My first denominator already has the 2, already has the x minus 1, just needs the x minus 3. Top and bottom. I notice I'll have to do some distributing up top. My next denominator already has the x minus 3 and the x minus 1. All that's missing is the 2. I also want to be really careful about all these minus signs I see in this problem. So my next step is to rewrite this as one fraction. I already know my denominator. Distribute up top, we end up with x squared minus x minus 6 minus 2 times negative 2x is negative 4x. 2 times negative 1 is negative 2. Notice I used parentheses because I still need to distribute that minus sign. In other words, I need to change that to a plus, which changes all the signs on the inside. Now, last step, simplify. Looks like I have x squared plus 3x minus 4 up top to x minus 1, x minus 3 on the bottom. In the last example, we tried Clinton magic to simplify the top even further. It didn't work. Let's see if it does this time. Negative 4 times 5 times positive 1. We need 2 numbers that multiply to give negative 4, add to give negative 3. I believe this time we can find some. So we have to do that. It's not considered simplified unless we factor all the way down. So I end up with my x plus 4, x minus 1. And as you can see, there was a reason we did this. Notice something cancels out now. If you don't do that, your final answer is not quite correct. You need that simplified answer. And you don't actually need the parentheses around the x plus 4. If you have them, it's okay. Either one of those answers is fine. That's it. At this point, go ahead and pause the video and practice these guided practice problems. The first two, you just need to find the LCM. On the next four, you have to find the LCM. You have to apply it and simplify your answer. Go ahead and do that now. Our last big idea in this section, difficulty level 3 of 3, is complex fractions. That means you have fractions inside your fractions. So a complex fraction might look something like this. If you think that looks scary, welcome to the club, but you'll have to get over it. And we're not going to be doing this with numbers, we're going to be doing this with rational expressions. The strategy is going to be to find the LCM of the entire problem, all the LCMs. So I've got to deal with four numbers this time. I've got 2, 5, 7, and 3. None of those actually factor, so I have to just multiply them all together. 210 is my LCM. So what you actually have to do is multiply the top and the bottom by that LCM. This will make all the fractions go away. We're going to look at that with rational expressions. So right now, go ahead and pause the video and write down all of the denominators that you see. See if your answers match up with mine. I see an x plus 4. I see another x plus 4. And I see an x. One nice thing about this problem is we don't have to factor any of those. They don't factor. Next up, just like before, I start looking for my highest degrees, for my LCM. I see an x plus 4 to the first. I see another x plus 4 to the first. So my highest power of x plus 4 is to the first. Next thing I see in my LCM is my x. I see an x to the first, and that's the only x I see. So I've got my LCM. So I've got to multiply this whole top times x plus 4 times x, this whole bottom times x plus 4 times x. Let's look at what happens. You could really think of these both as being over 1 if it helps you. X plus 4 and x plus 4 cancel out. All we're left with is 5x. On the bottom, we have to distribute this LCM. On the first one, the x plus 4's cancel out. And all we're left with is 1x. On the next piece, as we distribute, the x's cancel out. All we're left with is 2 times x plus 4. If you stop there, you're not quite done. Simplify this. Pause the video and try that on your own. Should have ended up with something like this. You also should be trying to factor the top and bottom, but neither of them factor. So we stop. At this point, go ahead and try these three. For all three of them, you need to first identify your LCM and then multiply that through the entire top and the entire bottom. These are the hardest problems of the lesson. They will be on your quiz and test.